First things first, you need to be able to graph a line in order to graph an inequality. Other than that, it's almost exactly the same thing. So to start, let's do kind of a simple example here, and I'm going to graph the line x is less than 2. Whenever we graphed x is less than 2 on a number line, watch. Number line, it looks like this. I'd put like a 0 point, then I'd put a 2, and then I'd circle it, and I'd shade in the direction of the numbers that are smaller than 2, which is that direction. That is neat, and that is fun, and that is not what we're doing, because now we're going to graph it in 2 dimensions. We're going to graph it like this. So here is x is less than 2, and to graph x is less than 2, I'm going to take the same idea I just did, but I'm going to expand it to 2 dimensions, having an x-axis and a y-axis. And what I'm going to do is I'm going to kind of ignore this first part. I know you can't do this, but I'm going to so that you don't look at it, so you can look at what we're actually doing. So I'm going to shrink this down, just kind of throw it off to the side. We're going to look and focus in on this. So to graph this, to figure out how to graph x is less than 2, I want to first graph x equals 2. Now, if I pop back over to our cheat sheet, and yes, I'm going to pause this and do this is the cheat sheet as we had it, and one of the things that we said is all x equals a constant equations are vertical with slope undefined. I'm looking for the link between x equals line and vertical. X equals lines are vertical. So if I go back to our notes, they're just doing x equals 2 is a vertical line. Now, I'm going to graph it, but I'm going to do it very faintly, well, as faint as I can. Don't put that down yet, because the second is decide, is it a dotted line or a solid? If I look at this, this is x is less than 2, and that means that I want to actually take this line and break it up. So this is the only time I'm going to do this, but I'm actually going to take the eraser and just kind of snap through and kind of break that up. I can actually set this eraser so it doesn't erase everything, and that's okay. That's a decent enough eraser. Let's go back to the stroke eraser so I can erase that. Okay. Last, after we've graphed the line and we put a dotted or solid line, then I should make this red to match it. Then I'm going to decide which direction to shade. Which direction? This is less than, and everything less than 2 would be to the left. But one way to do it is to test 0, 0, since that's not actually a point on this curve. So if I test 0, 0, I just plug, well, I can't plug 0 in for y, but I can plug 0 in for x. I'm going to test it in here. So what I get is 0 for x is less than 2, and that is true. Since that is true, I'm going to go where the point 0, 0 was, and I'm going to shade in that direction. And here's how I want you to shade. Parallel or perpendicular lines to our line. I just want you to do very, very faint but complete shading like this. Don't go scribbling and go crazy on me. But that's the shading. And that's it. That's your solution. That is x is less than 2 in a 3 dimensions. So if I blow this back up, if I attempt to blow this back up, and oh, poop. Okay, well, we're going to have to move it down. And I compare it. You can see that the comparison is kind of interesting. On 1 dimension, it just kind of moves in that way. But in 2 dimensions, it's actually this entire region. But it's the same thing. And an open circle in 1 dimension is the same as a dotted line in 2 dimensions. Okay, let's try another one. Let's go y is greater than or equal to -7/2. Well, we're going to follow the same process. I'm going to first graph y equals -7/2. And while I'm doing that, I'm just going to quickly decide, is it a dotted or is it a solid line? Well, it's y is greater than or equal to, and whenever we did that on a number line, that was a solid, like, closed circle. So this is going to be a solid line because that's what the greater than or equal to part means. That's our graphical interpretation of it. So I'm going to throw down a grid again with an x-axis and y-axis, although I'm not going to label them this time because I don't need to. But I'm going to throw down a grid, and we're going to decide what is -7/2. Well, half of 7 is 3.5, or 3.5, so that's -3.5. And that's a y equals. If I go back to that cheat sheet again, Okay, now I know how to access it quickly. I know that all y equals are constant, or y equals constants are horizontal with the slope equals 0. So I'm looking for a horizontal line at y equals negative 3.5, and that would be right here. There's negative 3.5, or 0, negative 3.5. And so if I kind of just do this very carefully, because I can't really click in there. There we go. It's a solid. And then lastly, I'm going to shade which direction. Well, greater than negative 7.5 means bigger numbers. That's, up towards the positive y. Also, if I test 0, 0, and I plug 0 in for y, because I can't really plug it in for x, I get 0 is greater than or equal to negative 7.2. That is also true. Since that's true, I'm going to shade where that point 0, 0 was, and I'm going to shade in that direction. Okay, so let's see how this works when we have a slant line. Let's do y is less than 7x. Actually, yes. Y is less than 7x minus 2. So 7x minus 2 is going to be a pretty steep slope. I'm going to not put ABC now, but I'm just going to kind of do it. So we're going to put a graph down. Remember that we have a y-intercept of negative 2 and a slope of 7. So I'm going to go down 2, then up 7, right 1. And I'm going to do a down 7, left 1, just because I can. And I'll connect these. Okay. And up, I forgot to break up my line, because it's a dotted line. So hopefully you saw that, but I'm going to use the little eraser thing. I guess I lied. I'm using it one more time. So breaking up my line, breaking up my line. This is where you kind of have to obviously take your eraser if you're doing it like this. Sorry, little axis line, but it's for a good cause. Oops, that can't happen. Okay, almost done. Line broken up pretty sufficiently. This is harder than it looks. Okay, I kind of broke up the axis there, but I'll let it live. So there's my broken up line. And then lastly, we have to decide which direction. Well, y is less than means down, but really a good way to do this is to test 0, 0, because 0, 0 is this point right here. Well, if I plug it in for y and x, I get 0 is less than 7 times 0 minus 2, which is 0 is less than negative 2. Oops. That is false. So I'm not going to shade where 0, 0 is, because when I plug 0, 0 in, I get a false statement. So I'm going to shade the other side. I'm going to shade over here, where 0, 0 is not. Number 4. Let's do y is less than negative x. So let's kind of go back to the ABCs here of this. Step A, graph y equals x. And so if I kind of throw that down and start to graph it, y equals x is a y-intercept of 0, because remember that's y equals x plus 0, and a slope of 1 over 1, or just 1. So slope here, and before I put the graph down, let's decide, is it dotted or solid? And it's y is less than, so it's going to be a dotted one again. So I'm going to go point here, and I can kind of do these little points when I do my y-intercept of 0 and slope of 1. And notice how it's kind of breaking up right now. If you sort of do this neatly, you can actually do a nice little dotted line just by sort of following those point by point, and it can look somewhat straight because you're still going by the guide points that you put in. And it won't look too bad. Okay, that looks kind of bloody, but at least it's, it's a straight dotted line. Okay, big problem here. I can't test 0, 0, and I can't do that because 0, 0 is on the line itself. I mean, if I plug 0, 0 in, I get 0 is less than 0, and that's not true. So I can't test 0, 0. I'm going to have to pick another point. Don't pick 1, 1. That's the same problem. Let's pick, like, I don't know, any point that's not on this curve. Heck, let's pick this point right here. That is the point 2, 1. Okay? We're going to test 2, 1. If I plug 2 in for x and 1 in for y, I get 1 is less than negative 2. Let's see, is that right? Yeah, I get 1 is less than negative 2. You can catch me on this one because I made a mistake here. And I'm not going to erase this because it's going to be too... Well, I'm not going to delete this. The mistake was that right here, I made it negative x and x. So since I graphed x, we're just going to go with x. I'm going to cut the negative here. So kill that, make it a positive. That means that 1 is less than 2, which is true. So that was the only way, or only place that I made this mistake. So again, kind of delete that negative. Sorry. 1 is less than 2, which is true. I kind of had to erase that because I looked at that and said 1 is not less than negative 2, but it was a less than, so it should be shading down, so something was wrong. Anyway, we shade in the direction of the point we picked, since that satisfies the one that we actually graphed. Okay, let's do one more. Actually, let's go ahead and do y is less than negative x just to show you the difference. So I'm going to do what that one should have been right now. Y is less than negative x. And I'll do this really quick. I'm going to put the grid down. Oops. Go ahead and graph on that grid the line y equals negative x, which is what I should have done before. So I'm going to graph that also as a solid or a dashed line. And if I do that with a y-intercept of 0 and a slope of negative 1, that's basically the same slope but in the opposite direction. If you just go from corner to corner on these boxes, you'll get it going pretty good. It's the same idea as before. You shouldn't really have to draw those points. Just make sure you go corner to corner on the boxes. And then, in terms of which direction to shade, test another point. Why don't I pick that same point? We're going to test 2, 1. So if I plug that in here, I get 1 is less than a negative 2, and that is false. And here's 2, 1, so I'm going to pick and shade the other side. Now, if you look at both of these graphs that we just did, you can see that we've shaded below. When I shade, it's not left or right. Since it's talking about y, it's top or bottom, up or top or below. Okay, let's go to number 6. 2x minus 3y is greater than 6. This is where the test point comes in handy. So I'm going to go back to the ABCs here. A, graph the line. Well, I'm going to graph 2x minus 3y equals 6, but I'm going to solve it for y so I can graph it in slope-intercept form. Negative 3y equals negative 2x plus 6, or y is equal to 2/3 x minus 2. If I do y is equal to 2/3 x minus 2 and I graph that, I'm going to have to decide, is it a solid line or is it a dashed line? This one's a dashed. And then negative 2 means a y-intercept of negative 2 with a slope of up 2 over 3. And I'm going to sort of put a few points down there so I can get this looking good. And then I'm going to sketch. Okay, once you've got that down, then I'm going to test my point. So I kind of part B was solid or dashed. And I picked dashed. And then part C was to test. Can I test 0, 0? Yes, I can. So 0, 0 is a good one to test. And if I plug 0 in, I get 0 minus 0 is greater than 6. That is not true. 0 is not greater than 6. That's false. So 0, 0 is here, but I'm going to shade on the other side because I don't want to shade where 0, 0 is. And that's enough for now.